Good morning everyone. Welcome back to grade 4 mathematics class. How are you all doing today? So today we are starting a new chapter. It's chapter 8, patterns and symmetry. So what do you mean by a pattern? Generally, when something is repeating or when we can predict what comes next, we say there is a pattern. So how would you define a pattern? A pattern can be defined as a definite sequence of shapes, numbers or letters which are repeated over and over again. So where can we see patterns? We can see patterns all around us. You can see patterns in fruits, flowers, vegetables. We can see patterns in the plant and animal kingdom. You can see patterns in your house, the beautiful Rangoli designs that you make during Diwali. Even the dress you're wearing now may have some patterns on it. And you can see beautiful patterns in architecture all around the world, like in the case of these monuments. Now, talking about patterns, let's see the case of patterns in numbers. When you say pattern in numbers, it means it is a sequence of numbers that follow a certain pattern rule or logic. And patterns in numbers can be growing or increasing patterns, decreasing patterns or repeating patterns. Now let's see examples for each of these. Look at the first pattern, 1, 3, 5, 7, 9. It goes on like that. And the numbers seem to be increasing in their value as the pattern is proceeding. So this kind of pattern is called a growing or increasing pattern. And can you identify the pattern rule or the logic or the relationship between adjacent numbers in this pattern? See the numbers 1 and 3. 1 plus 2 is equal to 3. And 3 and 5, 3 plus 2 is equal to 5. 5 and 7, 5 plus 2 equal to 7. So there seems a difference of 2 is there between adjacent numbers. So this is the pattern rule or logic for this number sequence. So if that is the case, can you predict what is the number that comes after the number 15? It would be 15 plus 2 is equal to 17. Clear? Now look at the next example, 45, 40, 35, 30. The numbers in the series or the sequence seem to be decreasing in their value. So these type of patterns are called decreasing patterns. And can you identify the pattern rule? 45 and 40. It has a difference of 5 and 5 is subtracted from 45 to get 40. Then 40 and 35. 5 is subtracted from 40 to get 35. 35 and 30. Again 5 is subtracted from 35 to get 30. So can you predict the next number? It would be 30 minus 5 is equal to 25. So that is how this pattern is proceeding. Now the last one, 7, 8, 9, 7, 8, 9, 7, 8, 9. It seems that the number 7, 8, 9 is repeating. So this is a repeating pattern. So can you predict what comes after the number 7 here? It would be 8, 9, then again 7, 8, 9 and goes on like that. So I hope you are clear with the different types of patterns and the examples we discussed here. Now, symmetry. We have already learned about symmetry in your lower classes. What do you mean by symmetry? So when you can divide or fold an object or shape along a line into identical halves or mirror images, we say it has symmetry or we say it has line symmetry. Look at these pictures given here. And in each of the picture, we can see a dotted line, and along this dotted line, you can fold or divide this image into equal halves or identical halves or mirror images. And these mirror images or equal halves will look exactly the same as that of the other half. So we say these are all symmetric images. And the line passing through it, which divides it into identical halves, that line is called the line of symmetry. So a shape is symmetrical when one half of the shape is exactly like the other half and the line dividing these images is called the line of symmetry. Clear? Now, let's talk about tiling. You have learned this in your lower classes as well. Tiling means you are covering a surface with some flat shapes in such a way that there are no gaps or overlaps in between. It is called tiling, or it's also called tessellation. So, when we create a pattern using repetition of geometric shapes with no overlaps or gaps in between, we call it as tiling or tessellation. You can see some examples of tessellations or tiling here. Look at the first picture. Here you can see a tessellation made of squares. Here there is a tessellation made of triangles, and here you can see a tessellation made of hexagons. Now, these are the three regular polygons which can tessellate: square, triangle and hexagon. Now, look at the next picture. You can see a beautiful tiling or tessellation of floor tiles in a room. And here in this picture, you can see a honeycomb, which is a typical example of tessellation from nature. So children, as a homework, you have to go through these concepts mentioned in page number 114, which is the Let's Recall page. And there are a few questions given through page 114 and 115. You have to go through these questions and you can work out these questions in your textbook itself, and you can take a picture afterwards and send us through Teams. So that's all for today, children. We'll meet in the next class with a new topic. Till then, bye.